The current video is an attempt to solve a linear inequality using the test function on a TI-84. So we're going to solve the inequality negative 2x minus 4 is greater than x plus 5 using that test function on the TI-84. First of all, we go to our y button and we let y1 be equal to the left-hand side of the inequality, the negative 2x minus 4. We let y2 be equal to x plus 5, or the right side of the inequality. We then turn both of these off, meaning that they are not going to be active. We go to y3 and we use the VARS button and we select y-vars and then we select function. When we press enter, we select 3 or y1 and we enter the inequality sign from the second math, which is the test function. Very important, the second math test function, and we select number 3, greater than, to match our problem. And then last we use vars again and take the y-vars and we select y2. So now what we have, if we press the table for y3, is we have the test to determine if indeed y1 is greater than y2, and we can look at what values we have. So let's look at a shot of those tables. Well, here we have the y1, and we've set it equal to a negative 2x minus 4. We have y2, and we have it equal to x plus 5. And note that both of those are off because they are not highlighted. We've turned those off. And down here we now have y3, which says that y1 is greater than y2 to match our inequality that we had originally. Now if we go over to the table, then in the table we note the values for y3 are all either 0 or 1. 1 meaning that the y3 is true, meaning that y1 is greater than y2. And if it's 0, it means that it isn't true. So we observe that with this negative 3, it is a 0, so that means it's not true. But for negative 4, negative 5, negative 6, negative 7, and so on, then the value is true. That is, y3 is true. So we conclude that as long as our value for x is smaller than a negative 3, then we will have a true inequality. So the 1 indicates that, and that's part of what we're using the test function to determine. So we can conclude that when x is less than a negative 3, the inequality is true. So the solution in interval notation is parentheses, negative infinity, comma, negative 3, parentheses, and that indicates to us as long as we pick a value smaller than 3, negative 3, not equal to, but smaller, then we have a true inequality. Now we could also solve this problem by simply using our rules of inequality. Now if we take the inequality negative 2x minus 4 is greater than x plus 5, and we subtract x from both sides, the order of the inequality stays the same as long as we subtract the same thing from both sides. So this reduces to a negative 3x minus 4 greater than 5. Next, if we add 4 to both sides of the inequality, again, if we add the same thing to both sides of an inequality, the order remains the same. And this reduces to a negative 3x greater than 9. Next, if we divide both sides of the inequality by a negative 3, then what happens is the order of the inequality reverses. That is, x is less than a negative 3. So what we've shown is that when we divide by the negative, we reverse the order, and we've shown that it reduces to the same interval notation that we were able to solve with our TI-84 using the test function, namely that it goes from negative infinity up to, but not including, a negative 3. This concludes our sample problem using the test function on a TI-83.